Hello. In this lecture, we will see what is the meaning of the maximum likelihood estimator. That is a part of the point estimators. Myself, Dr. Garg. Here, what is the content behind is that we will see firstly what is the motivations and the background of the MLE. What is the meaning of the likelihood function? How you can understand this MLE through the certain examples. And finally, we will find the MLE of the Bernoulli and the binomial distribution. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute. So suppose, firstly we will think about this background or the motivation behind the MLE. Suppose you have the random variable xi's which has assumed certain probability distribution. So it may be the Bernoulli, it may be the binomial, it may be the normal distribution, uniform distribution and so on, having some unknown parameter theta. What is the meaning of this unknown parameter? So for example, if you have the binomial distribution, we know that there are the two unknown parameters. So these are my theta 1 and theta 2. There is only one unknown parameter in the Poisson distribution, so this is called as the theta. Geometry distribution also has only one parameter, so this is a theta. Here there are the two unknown parameters for the normal distribution, so we call as theta 1 and theta 2. That's a and so on. So that's the meaning of the unknown parameters related to the distribution. Then the task of this MLE or the estimator is, since these are the unknown, then we have to find its substitute, or you can say we have to find its estimates. So our primary goal here is to find a point estimator u such that it is a good point estimator. Because it's a point estimator, so our target is to find the good. So what is the property of the good? As we discussed in the point estimator lecture, that it must be the unbiased, it must be the consistent, it must be the sufficient, and so on. That is the property of the point estimator. So where xi's are my observed samples. In other words, what you can say that our goal is to find the good estimator of this unknown parameter theta using the sample information. So these are my samples informations are there, which has a random nature. How you can do that? How you can do that? This is done with the help of the maximum likelihood estimator, that is MLE. It is a technique which are used to estimate the parameter of the given distribution, that is which is a technique which are used to estimate the parameter theta using some observed data, that is using the sample information. How? For example, if you have the population which follows the normal distribution, that's we know that it's a follow the normal distribution. For example, if I say collection of height of the students in a certain university, so all of you know that in a certain university there are so many students appears, so it means it follows the normal distribution. But what is the mean and the variances of the heights of the student? That is always unknown to us. So that means the mean and variances are unknown. So how you can do that? We will take a one sample, some students are there, and then we will try to estimate whether that mean belongs to them or not. So that MLE can be used to estimate them using the limiting sample of the population. That's the purpose of this MLE. That is, whenever you want to find the population mean, population parameters, we use the MLE as the estimation. For example, how you can do that? Suppose I just consider the weight of the randomly selected Indian females college students which are normally distributed, but they have the unknown means and the unknown standard deviation. So I consider the sample of the 10 Indian females whose weights are given like here. These are in the pounds are there. So based on these 10 Indian females, your target is to identify the likelihood function. Likelihood function is also called as the maximum likelihood function, and the maximum likelihood estimators of this population variance, population mean mu. Similarly, we can find the estimator for the sigma based on these 10, based on this sample of the 10 elements. So it seems that it is reasonable to be the good estimator of the unknown parameter theta. Why? Because it will maximize the probability. What is the meaning of the probabilities? Probability means the likelihood of the occurrence. So that's why this is called as the likelihood function, because our target is to maximize the probability, that is maximize the likelihood. So that's why I hope now you can understand what is the meaning, why we call as the maximum likelihood. Now what is the definition of that is, suppose you have some samples are there which are independent and identically distributed variables which are taken from some probability distribution. So that may follows the normal, that may follows the binomial, that may follows the exponential b, and that depends upon the certain parameters theta. So that theta is depending upon the populations are there. then the goal of this MLE is to maximize the likelihood function, that is here. Remember, this is not the conditional probability because this is not the event. Remember, if you define this conditional probability, here A and B are my events, but here these are my random variables and this theta is my parameter. So this is not the conditional probability. So we can define this as a probability that's called as the joint density function, and it can be written because they are the independent. So I can write this function as of x1 over the parameter this, since they are independent, so I can multiply them, x2 over the parameter this, and so on, lastly xn over the parameter this. So now I can write this as product of this. Now what is the rule for the maximization is we will take the first derivative as a 0, second derivative as a less than 0. But sometimes, since as the function distribution function is a complex, it is very difficult to take the derivative are there. So we can instead of the derivative we can take as the logarithm function. Why? Because logarithm is a non-decreasing function. So maximizing the L, it's same as that of maximizing the log L. Now, or in other words, we can say that the log likelihood function are easier to follow instead of this L. So what is that? If you take as a log of this, so what is that? All of you know that what is the log of the product? Log of the product is nothing but sum of their logs are there. So I can write here as a summation. Now you can see that we can easily take the differentiation of this instead of this product form. Now it's again depending upon this function f, whether it's a discrete or continuous. For example, once it is a discrete function, then it is one of the simplest case are there because all the parameters and the distributions are discrete nature, which has finite possibles. For example, if I say how you can find the maximal likelihood speed. So say an unfair coin is flipped 100 times and 61 is the number of the head occurs. It means, what is the meaning of that? 39 times tail occurs. The coin has the probability 1/3, 1/2 and 2/3 of flipping the head. So what is that? Which of the following is the maximum likelihood estimator are there? So how you can find the maximum likelihood estimators? That's a very simple, don't worry about that. So as the coin is tossed 100 times, so it follows the binomial distribution. So once it's a binomial distribution, we know that it's the PMF is my here. Now what is given to you? These are given as the probabilities. That is the value of the P is given to you. And which of the following is the maximum likelihood estimator of the head? How many heads you have given is 61. So that is X is my 61. So our target is to find the probability of the head is 61. That is the parameter theta. So theta is my probability. So that is either the probability is 1/3, either the probability 1/2 or 2/3. So our target is to find this. So we can substitute this value in here. N, what is the N is my 100. So this value is my 100. X is my 61 for the first case. Probability is 1/3. Q is my 2/3. So similarly for here, you can find this value. Similarly for the here, you can find this value. So after the calculation, since our target is to maximum likelihood function, so you can check which one is the maximum of them. So you can see this value is the maximum. So this value is corresponding to which probabilities? Because this is the parameter of the theta. So since this value is the maximum, so the maximum likelihood occurrence for the P is the probability of the head is my 2/3. If you look about the second example, same example I have considered here, but instead of considering these three probabilities, I have considered nothing about the coin. Then how you can maximize them? How you can find the MLE of the probability? Again, since it is 100 times, so the maximum likelihood now in this case here. Since our target is to maximize this function over the domain 0, 1. So what is the rule for the maximization? That you have to take the derivatives as a 0. Since there is a no product form, so how you can derivative them? This is the constant part. So you have to take this as a first function, this as a second function. So once you will take the derivative, you will get this as of here. After the simplify, you will get this expression. And once it will be 0, so it means either the P is 0, P is 1 or P is 61/100. So now you have to check that which one is the maximum are there. Now you get the three probabilities are there. Rest of the tasks are similar. Your target is to find the values at the 61 head with probability 0, with probability 61 by 100, with probability p is equal to 1. Clearly sees that whenever p is equal to 0, so what is the answer of this? It's a 0. When p is equal to 1, the answer is again 0. And this answer is a non-zero. So what is the maximum of them? Clearly says that this will be the maximum of this. Hence, the likelihood of this probability is my 61 by 100. Now, how you can find the maximum likelihood estimator for the Bernoulli distribution? What is the Bernoulli distribution is? So, if you have some random samples, assume that xi's are the independent Bernoulli distribution of the students picking a course of the statistics with the unknown parameter p, because we know that in case of the Bernoulli distribution, how many unknown parameters is? Only one, that is a p. Find the maximum likelihood of the p. What is the p? Is proportion of the student who select the statistics subject. So define the Bernoulli distribution as here, because we know that the Bernoulli distribution takes either 1 or take 0. 1 means if the student select a subject statistics, and 0 means it does not select the statistics subject. What is the PMF? What is the probability mass function of the Bernoulli distribution is here. Then our target is to maximize the value of this. How you can maximize them? That's again very simple. You can take as a derivative, or else you can take as a logarithm also. If you want to take as a logarithm, then you can also take as a logarithm. Then the likelihood function written like here, because this is consists of the how many samples? N samples are there. So this is only for the 1. So the total likelihood function are here. We can substitute this f values here. So we can substitute the value here. We will get this value. Since this is the product of here, so I can write this as a summation of this and this. Now, what is the rule for the maximization? You can take as a logarithm of this, log of this plus log of this. So you can take power as a outside and so on. Now for the maximization, your target is to take the derivative as a 0. So what is the derivative with respect to the p? This part is a constant, so this is my nothing but 1 by p and so on. Now after the simplify, you can open this bracket. You can see this part is here because this is a negative side, so it can be taken here. Now once you will cross multiply, what will happen? This is xi minus p of here. This is np minus of xi into p. So this will be cancelled out. So what is the value of the p from here? You can easily calculate of this one. Now similarly, you can see that for the maximization, you can easily derive that. You can take the second derivative, substitute the value of p here, you will get as a negative. So therefore the estimator of p is nothing but my here. Also you can remember that in the Bernoulli distribution, if you remember that in the what is the mean of the Bernoulli distribution? This is nothing but the p. So you can see that this is also the mean of them. Similarly, how you can find the MLE of the binomial distribution? The same logic about there. If you have some x's random samples which are independent are there, you have to find the Bernoulli here. So this is the binomial distribution PMF. Then our target is to find the maximum likelihood of the p. We can write like here. So we can substitute the value here. Since again it is very difficult to take the derivative with respect to p of L because it's a product form are there. So we can simplify them as by using the logarithm. So we can take the log of ABC. What is a log of ABC? This is nothing but my log of A plus log of B plus log of C. So we can write like here, this. Now we can open this summation part inside that, because this part we can take as outside, because what is the log of A raised to power B? This is nothing but B log of A and so on. Now we can take this summation as inside. Now for the maximization, what is that? Your target is to max derivative as a 0. This part is independent of the p, so this will becomes a 0. This is my 1 by p and here. Now you can simplify them. How you can simplify them? This is 1 by p is here. You can see this part. You can see this is n minus of xi. I can open this as here. This is the constant value, so n will be outside. This is 1 minus of this. What is the summation of the 1 is n. N into n is n square. That's why this is my n square. And this is minus plus is there. So after the simplify, you will get as here. Can you find this will be cancelled out provided p is not be a 1. So after the simplify, you will get p as of here. Similarly, you can find the second derivative here. You can substitute this p value here. You will get this as always less than 0. So therefore, the maximum likelihood of the p is my here. And if you remember that, what is the mean of the binomial distribution? This is n into p. So if you take as a p here, what is that? N into p will be my 1, n will be cancelled out. This is again nothing but my mean. So that's the required substitution, required estimator of this MLE of the probability. So this is the way you can solve this MLE estimators are there. We will see in our next class how you can find the maximal likelihood estimate of the Poisson, the geometric distribution. Till then, follow this link for finding the various video. Best of luck, students.